Are you able to solve that problem? Okay, we will discuss that problem. First, we will see this potential transformer. Now, as what this potential transformer are mainly used for the measuring of your higher side voltages. Okay, for normal voltages, or you can say for low range voltages, there are already number of meters are available. For example, this voltmeter, okay, voltmeter and multimeter also, but the range is quite limited. If you exceed the range of voltages, then you will go through this potentiometer. So this potential transformer is nothing but the instrument transformer which is used for the protection and the measurement purpose in your power system. As we see, the working or the use of current transformer is for the measurement of current, and that will be give the signal, or you can say give the feedback to the this your relay and your circuit breaker. Accordingly, the situation which is either it is healthy condition or abnormal condition is arises, that other function of that relay and your circuit breaker work accordingly. The same way, this potential transformer working also same. You need to measure the uh, potential of your transmission line between two lines, and generally that potential is very high. So for that we are going to use this potential transformer. The same way, if any abnormal condition is happen, then that give the signal to other protective device, which is uh, executive which is execute their operation according to the potential which is measured by this potential transformer. Okay, so generally, this potential transformer, what do you mean by that? Uh, it is mainly used for the measurement of voltages. Okay, so you can relate this with this voltmeter. Okay, voltmeter. So voltmeter is used in parallel for measuring purpose. The same way, this potential transformer is also used in parallel for measurement of your voltages. As you see here, this is one example in which some supply is feeding to the load. Okay, this is a one example. Supply is feeding to the load. Assume this is a very high voltages. Example is also given here. In terms of this, 13.8 kilovolt is a source voltages, and it is feeding to the this load. Now, you need to measure the voltage between this line. So see, this connection nothing but your parallel connection. So in that, we our aim to measure the voltages, right? So generally, the primary of voltages is very high, and the secondary, we are set the secondary in our meter convenience. Okay, मीटर की आपकी जितनी जिस means according to your design of your meter, you need to set the number of turns here. Okay, so generally in standard format, the this potential transformer rating for the secondary winding, or you can say that secondary साइड का रेटिंग कितना होता है, अराउंड 100 वोल्ट टू 120 वोल्ट के रेंज में हम सेट करते हैं. बट मोस्ट ऑफ द टाइम हम कैसा 110 वोल्ट सेट करते हैं. ओके, बट यू कैन सेट द रेंज इन with this limit 100 volt to 120 volt, and if you take the average of this, you can consider as 110 volt. So that's why most of the this potential transformer, the output will be set at 110 volt. Okay, so the primary is depending on your this condition means a transmission line, and that on depending on that how much the source is connected to the load. Depending on that, your primary will decide it, right? But the secondary, you need to set the voltage at 110 volt. Now the same concept here, the number of turns, which is IP, and VP, which is equal to IS and VS. Okay, the same way, if the secondary voltage is small, right? As we said, the secondary voltage is 1110 volt. So this is compared to the primary voltage, this is small, right? So this is your small. If I compare these two voltages, so secondary voltage is small, the secondary current the secondary current for balancing is very high, and the primary current is low. So as you see here, the secondary current is high. It what do you mean that if the secondary current is very high, then you need to set the small resistance here, because our aim to measure the voltages, not to increase the losses, right? So we set very small means this. Okay. So for that, you need to see here uh, the overall resistance for the secondary winding is very small. But the voltmeter case, I also explained what is the functioning of voltmeter. Internal resistance is very high, so small amount of current flowing from that. Okay, so that's वो different है. यहाँ पे भी वही है एक्चुअली में. यहाँ पे जैसे आपका ये सेकेंडरी जो टाइम ये जो बता रहा हूँ ना मैं, ये इन टर्म्स ऑफ दिस वाइंडिंग के बता रहा हूँ. जैसे आपका फॉर एग्जांपल ये सेकेंडरी जो मैं बोल रहा हूँ यहाँ पे, secondary resistance is small. So this in terms of this winding, okay. So your losses will be less. Then further at the second this terminal, this is your primary. This whole circuit is nothing but your PT, okay. ये पूरा PT है आपका. इसका ये प्राइमरी साइड हो गया, ये सेकेंडरी साइड हो गया. So this is your primary side, and this is for your secondary side. So इसका जो ये वाला पार्ट है, यहाँ पे हम आपका नंबर ऑफ टर्न्स रिप्रेजेंट करेंगे. सो देयर आर लेस नंबर ऑफ टर्न्स आर यूजेस here. And then this is connected to your voltmeter. Then further this voltmeter have one internal circuit. So in that the resistance is high. So resistance is high, then the small amount of current flowing from this resistance depending on your these conditions. Sorry, class ले गए. This sorry,
लेक्चर कितने बजे लगे?
अभी 2 बजे तक.
ओके ओके. मेरे क्लास में चल रही है इन्फॉर्मेशन लेके नहीं.
कब से आपका लेक्चर?
हम आई थिंक पता नहीं, तुम लोग का फ्री हो जाएगा लेक्चर तो उसके बाद से देखेंगे.
ठीक.
थैंक यू.
Yes. So yes. So this internal structure is different, right? Which or we I already discussed in your module one. Okay, but overall the secondary winding resistance is less. Now, the number of terms is less here, because this is nothing but your step down transformer, because you are stepping down the this voltage, higher voltage to the specific range of your meter, which is 0 to 120 volt here for this case. But in standard, you can consider this 0 to 101 110 volt. Okay. Now, so this is a one thing for this potential transformer. Now the basically you can write down these uh, points. Potential transformer primary is connected in parallel with the load. Hence, it is also called shunt transformer, called as shunt transformer. जितने भी पॉइंट मैंने अभी बताया ना, आप सब उसको नोट डाउन करें. ओके. द स्टैंडर्ड रेटिंग, राइट डाउन यू. द स्टैंडर्ड potential transformer, secondary voltages, rating is in the range of 100 to 120 volt. But most of the potential transformer are designed for the voltage of 1010 volt. Okay. Okay. So one more point, the effect of the ratio error. See here, the effect of the ratio error and the phase error are less in potential transformer compared to current transformer, because it is involving with voltage measurement. Now, the one more thing is, for this potential transformer is also the limitation. If you going to measure above 100 kilovolt voltages measurement, then the cost of that potential transformer is increases. So what happening in that case, you need to use the capacity voltage transformer here. Now see here, सी यहाँ पे डेरिवेशन दिया हुआ है. इफ़ यू वांट टू डिस्कस दिस डेरिवेशन, सो मैं ये कल आपको करवाता हूँ, ठीक है. दिस इज़ अ एक ही सामने बुक. मैं शाम को कॉल करता हूँ आपको, थोड़ा बिजी था. चाचा मैं शाम को कॉल करता हूँ, थोड़ा बिजी हूँ. ओके. यस, दिस थिंग, सी, these are the comparison between these CTs and PTs. You can also refer these points. Okay, the potential transformer may be considered as a parallel transformer because it connected in parallel uh, with your load, or you can say between the lines. Okay, with the secondary nearly under the open circuit condition, whereas the current transformer may be through in series with a series transformer under the virtual short circuit conditions. So these are the conditions. Okay, so I request you to please go through this all these points, and there is also the equivalent circuit is same. uh, as it is a potential transformer, but the condition is what is that you need to set a relation with this primary side uh, voltages with your secondary side voltages. So here we need to use the refer circuit. Okay, now I will discuss this in your first lecture, the phasor diagram in your CT. Okay, the same way, if you going to see here, now see the equations. You can also set that observe that equation, which is nothing but your this equation. For example, if I have draw this Vs in terms of phasor, Es is nothing but your this Vs plus sum of all drop in your this resistance, right? So Vs nothing but your drop across your load end. Okay, and this is your winding resistance and this reactances. So just write all these things and draw it's your secondary side, right? So according to this, you can easily draw this all the circuitry. Okay, so basic is this is a difference, this main flux and this is a secondary flux is leading by 90 degree. In the same way, this primary and this is a magnetizing component, and this is a your wattful component, you can say. It is quite and this current is very small, right, compared to this magnetizing component, almost 80 to 90% uh, in no load current, in no load component. 80 to 90% of share with this magnetizing component. That's why the magnitude you can see here, the higher compared to this wattful component. So this is your net no load current, component current. So this is nothing but the sum of these two phases, and accordingly, this is a EP, this is a primary drop, and if I consider this VP, okay, terminal primary voltages, which is nothing but your drop of this side, okay, drop on this this impedance plus this EP, okay. So the same way, drop of this impedance plus EP, nothing but your this VP. Okay, so this IP is IP. How to calculate the IP? The IP you need to use. IP is nothing but your no load current component plus here you can refer when you when you avoid this coupling, then you need to set this secondary side of uh, current here, right? Secondary current refer to primary side. So this is a sum of these two things, and same way, which is already given in this. So by this way you can draw this is by n, which is nothing but your is dash, right? So this component, the sum of these two component, which is nothing but your IP here. See this IP, and because of this resistance, this is a vector, you can say transformation, you can consider it. ये वेक्टर को आप इसके पैरेलल में लेके जाओगे यहाँ पे, दिस इज योर आरपी. Okay, so this is drop across your resistance, and this is a inductive coil. So inductance current what happened in inductance, voltage is leading uh, in inductance, right? Voltage is leading in inductance, and so that this is your leading here, and sum of these two vector is nothing but your VP. ओके, सो जैसा आपका इक्विवेलेंट सर्किट है, अकॉर्डिंग टू दिस यू कैन इजीली ड्रॉ दिस सर्किटरी. नाउ there are some parameters which is defined here. Okay, so uh, mark that all parameter which is for example this angle of secondary loaded condition, which is specified in terms of this theta here. Okay, so this is nothing but your angle between this angle between of your XC by no theta. Actually this is the angle between the impedances. Okay, so theta, sorry, del is the angle between the phase angle of the secondary load circuited. Okay, and theta is a nothing but your angle between the secondary primary voltages and the secondary voltages. सो यहाँ पे कैसे हो जाएगा, सेकेंडरी वोल्टेज को हमने 180 डिग्री ट्रांसपोज किया है, तो मीन्स वो किया है, तो दैट्स वाई देयर इज़ अ माइनस साइन. सो ये पूरा डेरिवेशन है. ओके, and there are some parameters, so you can I can directly use these equations. Okay, this phase angle is nothing but your is by n. This is your for phase angle. Okay, and uh, what is this r value, which is nothing but your actual transformation ratio. Actual transformation ratio is nothing but your primary voltages to the secondary voltages. ओके, सो नाउ सी हेयर, सेकेंडरी वोल्टेजेस तो हमारा कितना होता है, अराउंड वन, कंपेयर टू प्राइमरी वोल्टेजेस लेस ही रहेगा. सो दिस आर वैल्यू इज ऑलवेज ग्रेटर देन वन फॉर दिस वोल्टेज ट्रांसफॉर्म. एंड इफ आई कंसिडर इन योर सी टी में क्या था, सी टी में प्राइमरी करंट डिवाइड बाय सेकेंडरी करंट. ठीक है, सो सी टी में दिस इज फॉर योर पी टी. If I consider CT prime, this R generally, R is nothing but your primary upon secondary. So primary current is higher compared to the secondary current. So this also greater than one. Okay, now एंड जो उसमें टर्न्स रेशियो जो मैंने लिखा था ना वो सही था. ठीक है, सो यू कैन रेफर दैट. For PT, what do you mean by turns ratio for this PT? So for PT, turns ratio is nothing but your primary turns divided by secondary turns. Okay, for PT, for PT turns ratio, which is denoted in small n, uh, nothing but your turns ratio, which is primary turns upon secondary turns. And for CT, turns ratio is nothing but your कितना स्पेस दिया था मैंने लास्ट लेक्चर में, आई थिंक. हाँ, so for CT is nothing but your secondary turns upon primary turns. Now if you consider CT में सेकेंडरी वोल्टेज हाई होता था, तो सेकेंडरी टर्न्स कितना होता था नॉर्मली, सेकेंडरी टर्न्स इज हायर राइट कंपेयर टू द प्राइमरी टर्न्स इन CT. So this turns ratio for CT is greater than of 1. And same case for your PT. For your PT, this is your step down transformer, right? Step down transformer. Then also this primary turns is increase, means primary turns is more than compared to the secondary turns. So this also increases by one. This increase by one. Okay. So this is here for the CT type. And what is the angle of this phase angle error is, note, please note this as well, which is nothing but your theta. If you see here, this is your actual ratio, and this is your phase angle. Okay, so this is nothing but your actual ratio for PT, which is n plus is by n here rp cos of del plus xp sin of del plus ie rp plus im xp divided by vs. Okay, so this is your vertical component and this is your magnetizing component. So depending on the notation, you can also use this uh, according to your notation. Okay, so किसी में ये W I W से डिनोट होगा, किसी में दिस I न्यू से डिनोट होगा. Okay, and this is RP. RP is nothing but your total resistance referred to primary, means total resistance whatever which is observed by your primary side. Okay, which also include the secondary resistance referred to primary. Okay, so this is your total resistance, and this is the only resistance from your primary side. And for this phase angle theta, what is the formula for that? See here, this is a phase angle. So it is an angle between this VP and VS. VP means supply voltages, VS from load side voltages. Okay, this is the terminal voltages. Means you can say the this phase angle is nothing but here two term angle between these two terminal voltages, which is sending end voltages and receiving end voltages. Now this this is nothing but your IS by N, which is XP cos of del minus RP sin of del plus IE XP minus IM RP divided by NVS. This in terms of radian. So this theta angle you can also convert in terms of degree. Okay, and you can also convert in terms of this minute or second. Okay, depending on you need, आपको जिस फॉर्मेट में चाहिए, then you can easily convert it. So this is the equations for your potential transformer, and some basic difference between this distribution transformer and potential transformer I would like to share with you. So if you see the differences between this DT means distribution transformer and PT means potential transformer. सो जनरली डिस्ट्रीब्यूशन ट्रांसफार्मर क्या होता है, जो आपके लोकल एरिया जो रहते हो जहाँ पे आप, ठीक है, सो वहाँ पे आपको जो भी सप्लाई की जाती है बाय द डिस्ट्रीब्यूटर. सो देयर इज़ अ वन ट्रांसफार्मर. So you can say that that is your distribution transformer. Okay, so and power, what do you mean by power transformer? At the generation end पे जो ट्रांसफार्मर यूज़ करते हैं उसे हम पावर ट्रांसफार्मर कहते हैं. Okay, so there are two types of transformer. One is this power transformer and distribution transformer, and this is your potential transformer. So now, in case of distribution transformer, how it design, distribution transformer किस लिए डिज़ाइन किया जाता है? It is designed for the change in load, right? Because it supply to the consumer. So consumer demand is vary time to time. So depending on that, that parameter must be considered while designing this distribution transformer. So this design design in loads design in loads the voltage लोड चेंज भी होता है तब भी हमारा वोल्टेजेस सेम ही रहता है राइट दिस तो वोल्टेज शुड भी मेंटेन होना चाहिए इसमें लोड चेंज होने के बाद भी बट हम पीटी की बात करेंगे तो हम तो वहाँ पे वोल्टेज को मेजर करना है ना लोड चेंज होने पे वहाँ पे पोटेंशियल कांस्टेंट नहीं रहना चाहिए फॉर द मेजरिंग पर्पस नहीं तो अगर वहाँ पे शॉर्ट कुछ फॉल्ट भी क्रिएट हो गया अगर आपका पोटेंशियल कांस्टेंट ही है सो नो नो यूज़ फॉर दैट सीट पीटी राइट कोई सेंस नहीं बनेगा उसमें उस केस में इस पीटी को यूज़ करने का सो यू कैन से फॉर दिस इन पीटी केस in PT case you can write here PT takes take care of voltage ratio between the primary and secondary. As we see, depending on that, you can calibrate your reading, right? कि secondary में इसमें से means this PT is maintain the ratio. It means one parameter is going up or down, the other parameter will be effect. So accordingly, you can check the what are the actual voltages are there in your system, and that signal will be sent to the your relay side. And the second is if we consider the construction side, then distribution transformer uses rectangular core, and this potential transformer uses circular core. Generally, we found this in circular core, and the distribution transformer. Generally, we seen that in rectangular core. In that also, there is a one shell type and core type transformer. In transformer, you uh, study this all types of uh, this core. Okay. Now, one more point is overloading overloading capacity of distribution transformer is 20 to 30% of full load, and the overloading capacity of potential transformer is potential transformer is 2 to 3 times 2 to 3% of full load. Okay, so these are the general the basic difference between this distribution transformer and potential transformer. And one more thing is for distribution transformer, we consider the main criteria, which is efficiency. Right here, we are considering efficiency factor. Okay, and you can this is the main criteria uh, while designing. So this is nothing but your efficiency. And in potential transformer, what are the main criteria is accuracy. Okay, because whatever the voltages are there, we know that voltages. So you can say that the accuracy is the important criteria. Is the main criteria. So that's small description about this potential transformer. And I insist, I request you to please go through that and please read out this point at once. You can easily understand. Okay. Now we are using these parameters while solving the problem. So there is a one problem. I search it and try to solve this problem. Write down the question. See, all component are given in that question. You just put the value and get the answer. Okay, and some assumption also you need to take care. For example, okay, first of all, write the question. A potential transformer with ratio 1000 to 100 volt has the following constant: primary resistance 95 ohm, primary reactance 65 ohm, secondary resistance 0.8 ohm, and the total equivalent reactance was nothing but your 100 ohm, and the no load current is 0.02 ampere at zero point 0.4 power factor. You need to calculate first phase angle error between primary and secondary at no load. Second one is load volt ampere at unity power factor. Load volt ampere for PT case, you can also write this as a burden, right? बर्डन बोल सकते हो इसको आप, जैसे प्राइमरी हमने जो देखा था, सेकेंडरी इसमें जो भी लोड आता है उसे हम बर्डन कहते हैं. ओके. सो इन फॉर दिस पीटी unity power factor and the corresponding one more point is corresponding, this is at unity power factor corresponding to zero phase angle. So these are the data is given to you. Try to solve it. What is data is given here, which is nothing but your this rp is provided you, which is nothing but your primary resistance, right? This is your rp, which is 95 ohms, and xp is given to you, the primary reactance, right? This is in small xp, which is 65 ohm, and secondary resistance, which is nothing but your rs, zero point 0.8 ohm, and total equivalent reactant, that is xp. So this is your xp, capital xp. Okay, total equivalent reactance is nothing but your 100 ohm. Now For the turns ratio, you can also find out that turns ratio in terms of your primary voltages and secondary voltages, right? So that turns ratio, what are the turns ratio is given here, right? Potential transformer with a turns ratio is this. So this is a potential transformer. That's why the turns ratio is EP by ES. So which is nothing but your 10 here. So N is nothing but your 10 here. Okay, N is 10, and the I naught. How to find out the I naught? I naught is I think I naught is given to you, right? Which is nothing but your no load current. So no load current is given at zero point 0.4 power factor. So you can able to find out the angle from this. See, I naught is nothing but your zero point 0.2 volt, zero point 0.2 ampere. Okay, and power factor angle which is provided you, which is nothing but your cos of phi naught, or you can also represent this phi naught in terms of alpha. Okay, that totally depends on your representation, guys. Okay, so don't be confused if some of book is using this phi naught with this alpha. Okay, so which is nothing but your zero point 0.4. So this alpha phi naught, or you can say alpha, is you can easily find from this side, and find that value of alpha, and then use and find this sign of alpha. So when you solve this, you will get this alpha is 0.917. Now, what is the wattful component is IE, or you can say core loss component is, which is nothing but your I naught cos of alpha, or phi naught. Phi naught, you can also use that phi naught notation here. Simple, put the value and find out what you will get here. Point 0.2 multiply by this. What is the cos phi naught is zero point 0.4. Cos of alpha is zero point 0.4. This is nothing but your cos of alpha. Okay, so this is your zero point 0.4. When you multiply it, you will get ampere. Similar way, this IM or I knew, as you study in your machine, this IM is also represented in terms of this I nu magnetizing component, which is nothing but your I naught sine of alpha. Okay, simple, put the value and get the answer. And after that, use that formula, which is theta formula. Okay, and find all this value, and at no load condition, at no, the hint is that at no load, at at no load, what are the secondary current is, you need to consider here zero. Okay, you need to consider here zero. That is the assumption. Okay, and for that you need you will get the theta some angle, and you can also transform that theta in terms of degree. Okay, and if the degree term, when you multiply by the 60, then that theta you can also able to represent in terms of minute. Okay, so this take this as your homework and try to solve this problem. And if and talking about the part B for the same problem. So for part B you need to find out the load volt ampere at unity power factor. So uh, those at unity power factor corresponding to the zero phase angle. So phase angle you need to consider zero here. Okay, and at so this is your part B. For part B, at unity power factor, cos of del, which is given here 1, and sine of del. Now if cos del is 1, what it means, del का कितना है, डेल का एंगल कितना है, जीरो, cos जीरो इक्वल टू वन, सो साइन जीरो इक्वल टू जीरो. Okay, so use this value in your equations of del and find out and equate this del with respect to 0, right? When you equate this del with respect to 0, because the condition is mentioned here, zero phase angle is mentioning on your part B. Okay, that's why. Now, when you equate you 0, you are able to find out this is value. ओके, आई एस वैल्यू आप यहाँ से निकाल लोगे इसका. सो आई एस वैल्यू आपको यहाँ पे मिलेगा इसका. एंड देन यू नीड टू फाइंड आउट द बर्डन. बर्डन क्या होता है, कितना लोड आपको सेकेंडरी में मिल रहा है. ओके, दैट इज नथिंग बट योर पावर लॉस, you can say power use from your main circuit, which is nothing but your is and bs. So for your zero power factor, sorry, unity power factor angle is zeros, right? So power loss is Vs into Is here. So put that value Is you are finding from this, and Vs is given to you, which is nothing but your secondary voltages, nothing but your 100 volt, right? Now, so Is multiplied by 100 is, so you will get the burden or this power loss on your secondary side, and the unit put in volt ampere format. So these are the process you need to do, simple put the value. Okay, and if I talking about the first numerical, which is I given to you as a homework. Wait a minute, I just open that PDF. Okay, ये प्रॉब्लम था, राइट? सो इसमें क्या दिया है आपको, दिस इज योर सेकेंडरी करंट. This is your secondary current, right? So this is your secondary current, and from this you can, with the help of turns ratio, you can also find out the I2 dash, right? I2 dash. Now, this बार मैग्नेट यूज हो रहा है, तो प्राइमरी टर्न्स कितना है, वन ही रहेगा आपका, राइट? प्राइमरी टर्न्स अगर वन है, then primary turns is 1. The secondary burden on pure resistance is 1 ohm. So this is your secondary side resistance, which is R2 or RS, right? This is your RS, and it draw the current of 5 ampere. Okay, so this is your IS, right? Secondary current, IS, or you can say I2, and magnitude of this core required is 250 ampere turn for your magnetization. So this is nothing but your 250 ampere turn is your magnetization, right? So which is nothing but your N1, क्योंकि प्राइमरी में ही आपका जो है मेन सर्किट रहेगा, राइट? सेकेंडरी तो आपका मेजरिंग पर्पस मीन्स 5 एम्पियर ही जा रहा है, सो मेन एक्साइटेशन तो आपका प्राइमरी से ही हो रहा है, राइट? सो दिस इज नथिंग बट योर N1 and I need. So you can also compare, uh, because the major contribution of no load current is by this magnetization current only. So you can treat it as this N1 I1 as nearly equal to the N1 I 0. Okay, so we are generally neglect the losses here. So from this you are able to find this IP, because primary current is nothing but your IP. So N1 IP, if we neglect these losses, so and N1 IP is nothing but your 250 here. So you can able to find those IP. Okay, N1 number of primary turn bar magnet bar is primary है, so one ही consider करना है. So this primary is nothing but your 250 ampere here. Okay, so this is your no load so this is your no load component. Okay, so this is your I naught, right? This is your I naught. So no load current, no load current. This is your no load current over. Now, if we're talking about this, what is the ratio of this I2 dash upon I2, which is nothing but your N2 by N1. Okay, N1 तो 1 ही है, so which is equal to N2. So I2 and I का relation क्या बना है यहाँ पे? I2 dash is nothing but your N2 into I2. So this I2 dash you can find out with the multiplication of this I2 with respect to this N2. Okay, so when you find out this value, so here you need to find out this N2 value. Okay, number of turns is not given here, right? So by which you can easily find out the number N2 here. So N2 is nothing but your 100 volt, 100 turns. Okay, you are able to find N2 here, which you will get the 100 turns. And this I2 dash, this is nothing but your I2 dash here, which is using in primary side, and this is your I2 current component. So and this is nothing but your this ratio. This ratio is nothing but your uh, nominal ratio. Okay, this N2 is a nominal ratio because see N2 is equal to this. So this is nothing but your nominal ratio, which is a rated primary ratio of the rated primary current upon rated secondary current. Okay, nominal ratio का formula क्या है? This is a nominal ratio, NR, right? Rated primary current divided by rated secondary current is nothing but your nominal ratio. Now, once you find out this nominal current ratio, wait, then use that percentage error concept. So here you need to find out the percentage error for me. This percentage error. So percentage error का formula क्या था यहाँ पे? See, nominal ratio आपने find कर लिया, ठीक है? Actual ratio आपको find करना है. So you need to find the actual ratio. So actual ratio कैसे find करोगे यहाँ पे आप? Actual ratio is nothing but your primary current, or you can say primary phasor divided by secondary phasor. Okay, this is your primary phasor divided by secondary phasor in terms of what? See here, क्या होगा बताओ? किधर गया? ये एक्चुअल रेशियो क्या होता है? एक्चुअल रेशियो मीन्स ट्रांसफॉर्मर रेशियो, राइट? ट्रांस हाँ, फॉर सिटी के लिए क्या तुम्हें करंट होगा ना, प्राइमरी वाइंडिंग करंट अपॉन सेकेंडरी वाइंडिंग करंट. सो प्राइमरी वाइंडिंग करंट भी क्या होगा यहाँ पे? प्राइमरी वाइंडिंग करंट में दो करंट का सम रहता है, वो फेजर सम रहता है वहाँ पे. सो यू नीड टू यूज द फेजर सम हेयर. ओके, not use directly that value, it is a phasor sum. So first of all, सर्किट डायग्राम तो हमने हमें पता ही है. So when you observe that, this is nothing but your I naught plus I2 dash. Okay, this is a phasor sum. Now, what is the concept here is I if you see this I2 dash, this is your main flux, right? This is a reference. Take this as your reference, which is near. If I consider in this question, we are consider this I nu is equal to your I naught. Okay, and this is it leading by 90 degree. Okay, so in this is your E2 and this is your I2, and for I2 reflection we refer to primary side. So this I2 is goes in effort is refer to primary side, right, in above side. So you need to add this uh, this I2 and I naught component. So I naught component कहाँ पे होगा, यहाँ पे होगा. So इसका फेजर सम कहाँ पे आएगा, somehow you need to use air side, right, इस साइड में कुछ आएगा. ओके, सो कैसे कैलकुलेट करेंगे इसका, अंडर रूट ऑफ take the under root of this, which is nothing but your, let's say this is your IP, which is nothing but your I naught plus I2 dash. Consider under root of square of this current. कितना है, आई नॉट कितना था, आई नॉट जो भी आएगा आपका, ठीक है, उसका वो स्क्वायर ले लेना, इसका भी इसका स्क्वायर ले लेना. सो दिस इज, यू विल गेट द दिस आई पी और यू कैन से आई वन. ओके, primary side current, and when you take the ratio of primary side current to the secondary side of current, you will get the value of this AR. फिर AR की वैल्यू मिलने के बाद क्या करोगे आप, put that this all values in that percentage error. ओके, यहाँ से आपको आई पी मिल जाएगा. देन ए आर इज, ए आर भी आपको फाइंड आउट हो जाएगा इससे, ठीक है, इससे आपका ए आर भी आ जाएगा. देन पुट दैट ऑल वैल्यू इन योर परसेंटेज आर. सो यहाँ से परसेंटेज आर पे जब आप वैल्यू पुट करोगे तब आपको ये भी मिल जाएगा. क्या निकालना था, परसेंटेज एरर निकालना था, राइट, रेशियो एरर निकालना था. ओके, रेशियो एरर. सो रेशियो एरर आएगा, आपका रेशियो एरर माइनस में आएगा यहाँ पर, ठीक है. सो रेशियो एरर निकलने के बाद वो बस, ओके, परसेंटेज में रहेगा. ओके, सो ये प्रॉब्लम इस तरह से सॉल्व करना है. प्रोसेस मैंने आपको बता दिया है, आप इसे फॉलो करो और इसकी जितनी भी न्यूमेरिकल वैल्यू आती है जिस सिंपल फॉर्मूले में पुट करो वो, सो यू विल गेट द फाइनल आंसर. सो अभी जो भी, ओके, सो टुमारो एक बार हम फिर से इसे देखेंगे, ठीक है, आपका सी टी पी टी का जो अदर कॉन्सेप्ट है मैं एक बार पढ़ता हूँ उसे, आप भी पढ़ो. ओके, ये जो ए के सावनी बुक में दिया है, and similar types of problem will be asked in your exam or in future as well when you study the power systems and other subjects. So there also you need to find this some parameters. So for that also you use these equations in that at that time. Okay, so equations आपको याद रहना चाहिए. And okay, so tomorrow I will also discuss the same, so with some new numericals and some other factors which I left for today's session. Okay, guys, you can leave now. Thank you.